What is up, guys? Back to another episode of the CSpreneur. This is the second part in the NXT Programming Series. Today we're going to be learning about how to use sensors, basic logic in the NXT Programming IDE, and we're going to be going further, and I'm going to be giving you a challenge to solve. Let's see if you can do it. Okay, so let's get started actually talking about the course of the program and how and what we're going to be doing in the program and what you guys are going to learn. So this program was originally created for a school in Austin, Texas called Summit Elementary. This is me, the curator, right here. So if you're watching this, you're either watching this at home or you're watching this at a school. And if you're at a school, then it was probably application based. So congratulations for making it into the program. So why are you here, first of all? Why do I have you guys here? So you're here to learn about the process and the fundamental knowledge used in robotics. And you're going to use that to create a better understanding of the field of robotics. And finally, we're going to kindle your interest in robotics and STEM. But honestly, if you guys are already here, I think all of you are overqualified in STEM and are very interested in robotics. So let's proceed. So if you guys are actually following along at a school, you will be graded. Here is your work policies for the course of the program. So we're going to have preparatory work, which is just a completion grade. So that's just, are you staying on task? And we might also be giving you quizzes in the near future, so just look out for that. Preparedness survey, so this thing's actually obsolete, so the course project actually will take up 70% of your grade. But don't worry about the grade too much, just worry about having fun and just having fun with robotics and making sure that you're learning throughout the course. This is just to keep you from not fooling around or anything like that. So a little bit on the outline of the course. We're going to be learning about the fundamentals of how NXT 2.0 kits work. Now, if you guys are following along on an NXT 3.0, then that's fine as well. So we're just going to be understanding how to program an NXT kit and how to build with an NXT kit. So we're also going to be focusing on basic logic. And if you're following along in the CSpreneur YouTube channel, then we're going to be building on this logic to be learning languages and coding languages like Java, Python, and more. We're also going to be learning basic digital electronics and more on the hardware side. Don't worry if you guys don't know what that means, you'll learn soon enough. We're also going to be learning software development, obviously, for programming the NXT kits and the engineering design process, because believe me, you're not going to get it right the first time. And if you are, then you are a child prodigy. Anyways, moving on. Classroom policies. Be ready to learn every single day. Don't give your curator a hard time. Be respectful to your peers, curator, and volunteers. They're donating their time to you, and your parents are probably helping you by driving you there. Just show respect. It's just the golden rule. Always think about your actions and safety implications. Be safe, guys. Don't eat the battery. Don't do anything crazy like that. Be respectful to the robot kits as well, because they are expensive, and they're if you're following along at school, they've probably been loaned to you, so just make sure that you're not fooling around with the kits or purposefully trying to damage them. Respect yourself, okay? Don't put yourself down, because if you guys are here, I know we're going to get through this. If you have any questions at all, feel free to shoot me an email or ask your curator any questions that you might have. Respect yourself and be open to learning, so make sure that you're in a growth mindset, and I'll put a link down in the description below on a TED Talk if you guys want to know more about the growth mindset versus the fixed mindset. And finally, be a problem solver. Don't just give up on the first time, because as I told you in the engineering design process, you're not going to get it right the first time. But seriously, don't give up. Be a problem solver. Solve those problems and get help from others, because that's why they're there. Lab rules. We had this rule at Summit Elementary. If your curator wants to do differently, just no food or drinks in the lab, or at least close to the computers. We did allow snacks outside of the lab though, so we just gave breaks. Curators, you guys can decide what to do in that regards. Structure of class. So again, the preparedness survey is kind of obsolete. We will email it to you if you want, so curators, feel free to shoot me an email, and I'll probably put my email in the description below for you guys to contact me. Or just send the CSpreneur an email. I also check that email pretty often. So then we're going to lecture on the topic for the day. If you guys are following along at home, then it's pretty structured for you guys. I'm just going to give you guys a lecture, and you guys can just solve the problem. And the link to the Google Drive for the problem and the challenge for that day will be linked. So just look down in the description below and follow along. So then we'll also have some group work time. And if you guys are just following along alone at home, that's fine as well. If you guys have any questions, feel free to look it up online. There's a great community online for Lego. And if you guys just don't find the answer, again, shoot me the email down in the description below. And finally, after all the lectures are completed, guess what? You guys are going to get a final challenge. The final challenge is pretty difficult, but it's fine. I mean, if you guys follow along in the course and you guys feel that you're getting everything in the mini challenges, you guys will be more than prepared for the final challenge. Finally, getting help. Don't be that guy that thinks he's super smart, because I know I was. I didn't need help from anybody else. Ask for help. It's not an issue. Just ask for help, and that's my advice to you guys. Just schedule for today. Obviously, this is just ballparking the numbers, but we're going to introduce the kids to you. We're going to go through the basic programming and completing basic challenges. If you guys are following along at home, this may take you longer, this may take you shorter. It's up to you. And just a wrap up and a review of what's going to happen. That's on there twice. Okay, schedule's on there twice. It's my fault. So let's get to know each other. If you guys are in groups at home following along, introduce yourself to each other if you guys already haven't, and go ahead and partner up. Right now, just feel free to pause the video and just partner up, and ask your partner these 4 questions to get to know them, because you guys are going to be spending time with them. Alright, so I've assumed that you paused the video, and we're actually going to be moving on to introducing the kids now. So, a little bit on how to get set up for today's video, and here are the series of steps. Okay, welcome back. So that's how to get set up for today's video. One more thing, my brother actually created the super cool ultrasonic sensor setup. If you guys want to replicate it, it's actually just the setup for this gigantic Rubik's Cube bot that I have here. It's kind of messy, so I don't want to show it, but that's fine. You guys can just attach an ultrasonic sensor however you please. Go ahead and be that problem solver. If not, then I'll also link in the description. I'll probably link some building instructions if you guys can't figure it out. Just follow the same process shown in those clips. So just attach the one end of the cable into the ultrasonic sensor and or infrared sensor if you guys are following along in an EB3, and plug the other end into one of the 1, 2, 3, 4 ports. And you guys might be wondering, when I showed you the clips of the brick here, let's just scroll down. When I showed you guys the clips of the brick, obviously it's different on an NXT 2.0, but there's A, B, C, and D. There's letters on one side, and then there's numbers on the other. Guys, pay attention, okay? Because this is actually important. A, B, C, and D are specifically for the motors, and 1, 2, 3, and 4 specifically for the sensors. Do not mix that up, because there will be repercussions and consequences. Just don't do it. So again, just make sure to plug in both of those sensors into the 1, 2, 3, 4 ports. So let's talk a little bit about what the sensors do. They look cool and all, but what's their purpose? So here's the colored light sensor. You can actually see that there's a red light shining there. It's on, which means it's powered on. I think my Mindstorm CV3 just ran out of battery power. That's not good, but we'll see what happens. Anyways, so this is, one end is plugged into the sensor, one end is plugged into the EV3 module, which means that it's officially connected and can also receive data going forth and back. So this sensor detects various things. One is color, one is the amount of light reflected back, which is reflected light ambience, and there's also more that you can figure out with that sensor. But these are the two that we're actually going to be using during this, and I'm not even sure if we'll get to the color, but we might. And so just a bit on the ultrasonic sensor. This one's actually pretty interesting. So let's assume that you are in the bathroom and you want to figure out a way to, and you guys might have even seen these paper towel dispensers in bathrooms now, but you actually just wave your hand in front of these, and what happens is the paper towel dispenser magically dispenses a piece of paper. How does that work? Well, there's your answer. It uses ultrasonic an ultrasonic sensor inside of it, so it detects the distance by sending out a high-pitched ping, but that's outside of the scope of this course. Basically, it just detects distance between it and an obstacle. So it'll say, I don't know, say 2 centimeters here. That's probably a horrible estimate. Probably 2 centimeters here, and probably around 10 centimeters here. Not sure if that's correct, but it's essentially just detecting the distance between it and an obstacle. So moving on, those are the 2 sensors we'll be using today, and I'll be teaching you a little bit more on the sensor and how to use it in the challenge later. So also a motor. The motor is very important because that's how you make your robot move. You know what? I think I will be showing you this elaborate contraption. This is a Rubik's Cube solving robot that I have broke to make this tutorial, but that's fine. So what you see here, let me just show that to you. What you see here, that's the motor. This is the motor that comes with the EV3. What you're seeing on screen is the motor that comes with the 2.0. On the EV3 you also get a 4th motor that looks like this. This is the 4th motor. It's slightly tinier, and it also contains less power than the larger motors. But so that's a little bit on the motors. That's how you're going to make your robot move, and we'll just discuss how to program that later on in the tutorial. So here's the brick for the NXT 2.0. That's what it looks like. Here's the brick for the EV3. I already showed that to you guys, so that doesn't matter. So go ahead and open up the NXT software on your computers, and yeah, so then we'll actually just get started programming the robot.